already, so I'll not go into that. Quick things about the session. This is introductory session. We'll go through the concepts. We'll go through the setup. We'll also discuss the use cases and the very important thing, the cost part. Cloud is not cheap. It's very costly. If you do not use it in a right way, it's going to cost you a lot. So we'll also keep that in mind. You can ask the questions in the chat box. I'll actually switch the windows and see if I can answer. Everyone else, if you think you can also answer any of the questions, feel free to answer as well. I'm open to that. First thing, we'll look at the overall data offering. Going to full screen. So overall database offering into the AWS, there are multiple database offerings. The Aurora, RDS, Redshift are the relational databases. DynamoDB is a key value, NoSQL database. Elasticache, which supports Redis and Memcached, is basically memory caching solutions. Very popular. DocumentDB has added very recently, almost a year and a half. We are using DocumentDB in productions, super database. This is basically DocumentDB at the moment is only compatible with MongoDB. So if you are using MongoDB hosted solution, or if you want to migrate your MongoDB into the cloud, I will definitely suggest go with DocumentDB. We are already using that in production. White column, that is Cassandra, again very new. I think this is very recently announced, just a few months back. Neptune, TimeStream, and QLDB are purpose built. So graph database, time series database, mainly used for the IoT, financial industries and stuff like that. Ledger, again for the finance and similar to the blockchain and those concepts. So it's also very recent, a year old, I would say. It was in preview until a few months back. So these are the popular offerings. What we will look today is Aurora, RDS, and DynamoDB, because these are the databases which most of the people start with. You need to store the data either with a relational database, table row format, or non-SQL, NoSQL databases, key value. One of the things which is not mentioned here, but it is a lot of the companies, a lot of people use that again as a database, is S3, which is basically an object store. You can actually save multiple format of files inside that. You can query it with Athena. You can actually do a lot of stuff. It is not a regular database because it is unstructured. You can say it's an unstructured database, but it is still there are a lot of use cases where the data is stored in S3 and then queried from there. So in most of my session, I go to this slide wherein which I show that if you are new to the AWS, if you are starting something, then there are a set of services which you need to be familiar with. These are the core services of AWS which will keep on coming, whether you are using it for the database purpose, if you are using it for the compute purpose, whether it's a serverless, containers, normal EC2, or any other services. These are some of the things which will keep coming back. So if you are new to AWS, I will highly recommend that you go through this concept first, and then you start the 3 screens. Okay, let me select screen. Yeah, I think I have multiple just one second. Let me stop and start. That might help. Okay, let me know which screen is now visible. So we haven't covered that many slides. Okay, PPT is available, so great. So if you are, if the audio was audible, so I just mentioned that there are multiple offerings of the database. I'll keep this in a non-full screen just so that it is visible. I'm sure it is visible to everyone. So there are multiple offerings of the database in the AWS cloud: relational, NoSQL, in-memory cache, DocumentDB, which is basically compatible with MongoDB, Keyspace, which is compatible with Cassandra, very new offering. Neptune is graph database, TimeStream is a time series database, and QLDB is basically a ledger database. So these are all purpose-built. The last few are purpose-built. General purpose databases are Aurora, RDS, DynamoDB, which you use for multiple use cases. Elasticache, again very popular. One of the thing which is not mentioned is S3 here. It is still used for a lot of data storage purpose, query purpose. So, but it is not your regular database offering. So that's why it is not listed here. Core services which will keep on coming, whether you are using something related to the database or you are using something some other services of the AWS. So I'll highly recommend that if you're not familiar with these concepts, please spend some time, understand this, go through this. It will make your learning of other services very easy. If your fundamental related to the cloud, AWS is clear, then the newer services or complicated services will become much easier. Terminology wise, first thing first, I'm not a DBA. I have never done extensive work around the database. My job is to select the right database for the purpose that we have. We all now, the trend wise, it is all microservices. Even in the serverless, you have functions as a service. So it is the growing trend is that you use the database backend, which is most suitable to your microservice. If you have 20 microservices, chances are you are using maybe 3 or 4 different kind of databases. Some which is pulling the data from the relational database, some which is pulling the data from the NoSQL database, some which is pulling the data from the Redis caching mechanism. So you never know. So one of the reasons why it is very, very important to understand the different terminologies regarding to the database. But if you are not DBA, it is fine. I'm not a DBA. We are still I'm still doing fine. We use a lot of different databases as long as it's purpose. And when we need very specific things, only at that time we bring some DBA into the picture. Other than that, it works. Starting from the top, a very general, applicable to the entire. Read and write in a single chunk. That is also very important when it comes to the database. That will determine that how fast you can actually pull and push the data. Latency, everything in the cloud is distributed, even though it looks as a single thing, but everything is divided. All the resources are virtual. They are connected internally via the software-defined networking and many other complicated virtualization technologies. So latency is also very important, that how much time it takes to read a chunk of data and how much time it takes to write the data. Queue length is again related to the latency and throughput. It determines how much of a data is still pending to write, go to the disk, and still into how many operations are still into the queue to perform. This is basically comes into the performance tuning and checking, debugging your database if it is not working. If it is working slow or not giving you the better performance. Burstable CPU is again a term which is related to the instances. So when you create a database for the RDS and Aurora, you need to give the instance size. Your instance size and configuration determines how fast, how better you can actually access your database. So the general instance which many of you are familiar if you are using EC2 is basically T-type, which is for the testing purpose. So it has a bus table as well. And then there are purpose-built instances like the R or D or X, and those are optimized for the RAM or CPU and those kind of things. Read replicas are very popular in the database area. It's basically an instance which is only focusing on reading the data from the disk and does not allow you to write anything. Those are, if you have a very high load application, then your one or a set of instances are just doing the writing, and you have a set of instances which are just doing the reading part, so that your writing operations are not compromised. TLS connections, this is compliance and security things. In my experience, all the applications that we have recently done in past few months to past couple of years, everyone asks for two things. One is, what is the security that you have around the databases? So the TLS SSL, which is how you are connected with the database, similar to the HTTPS. So everyone wants their websites or web applications to be HTTPS. Similar to that, in a lot of compliant environments, everyone wants their database to only serve data via the TLS SSL. So no SSL, if there is no SSL setup, they would like to have that setup instead of using the plain connection. TD in FLE is basically very low level thing. It is very important when you are saving the critical sensitive data. So TD is the term popularized by my MS SQL Microsoft. So this that actually automatically encrypts the data. And FLE is on the extreme other end. It is very complicated. It actually, you can select few fields and encrypt that. By default, there is no attached solution with any of the open currently database providers where you can actually selectively encrypt a field. You have to do it by code. TD is something which everyone offers. All of the offerings of the AWS has a TD, which is a KMS. So it actually transparently encrypts all the data at rest. It's an encryption at rest. Database structure, historically, it's considered to be one of the most complicated monolithic applications. So you install the database as a whole. You have the database engine, which is directly dependent onto the disk, what kind of disk that you provide, and it works in conjunction. So when we talk in the cloud, we have it divided into two parts. One is a compute section, which actually takes care of the reading and the writing part, executing your query, plotting your query, creating the time tables and all those things, and storage, which actually stores your data. So in AWS, there are three offerings: magnetic, general purpose, SSD, and provision IOPS. Magnetic is not recommended. It is not actually meant for frequent use. There are some use cases still, but otherwise it is not recommended. General purpose is basically an SSD. You can think of this as a normal hard disk that you have in your laptop, and SSD hard disk. So the normal hard disk has a magnetic drive inside it. It has a head, and SSD are solid state. So there is huge performance difference between the two. AWS and many other cloud providers, they have actually started upgrading their infrastructure rapidly. So 99%, if it is not mentioned, it is basically an SSD which is used as backend storage. And provision IOPS is basically the high throughput, high frequency IO operations, which actually, provision means you want a guaranteed input and output at a high level. So this is for the heavy frequency read and write operations. These are some of the general DB tasks that you do. We'll see how this relates to the RDS Aurora and DynamoDB part when we go to the further slides. So the patching, if you are installing, the usual thing when I started using the database, the first thing that we have to do is we have to download the database software. We have to install it somewhere. We have to make sure that all the patches are installed. It is secure. We have some kind of backup and restore, not restore. Only the backup jobs are running so that we can take the nightly backups or a weekly backup or monthly backup, stuff like that. And the basically hidden part is that there is some mechanism through which we are also deleting those backups. Otherwise, it will keep on growing. When you take the manual backups, you are actually always taking the full database backup. So that's a very big concern when you have the right databases, and cloud databases actually helps you solve all of these things in a silent, transparent way. Right sizing, again, it is a very important and a complicated topic at the same time. What is the right size? What exactly should be the size of your database instance when you are starting? Should it be small, medium, large? How fast you can actually upgrade, downgrade, stuff like that. That is very, very difficult to actually estimate when you are doing something on-prem or you are hosting it manually onto an EC2. But with cloud databases, it is very, very simple to go with right sizing. Security encryption, again, very difficult to do manually. That's one of the reasons why I have decided not to be a DBA. I always go with a managed solution, which gives all of these options right there, and I don't need to spend time configuring this manually. Performance tuning, logs, and security. These are the things which has, if you are not doing anything, which has a lot of options by default, enabled or disabled. Many of us do not go inside those configurations when we install a database manually onto a virtual machine or somewhere. But when you go into the productions, these things become very important. We have seen a few installation in which these things are important, even though we have not yet started. So performance logs are stored where, security, encryption, or even the backup and restore, or the DR, disaster recovery strategies are very important topics before, even in the early stage of discussion. We'll go into the RDS and Aurora MySQL differences later in the slides. So Ayush, please wait for some time. So self-managed versus the managed databases. These are some of the concepts I'm laying out before we go into that. So we'll go through the RDS and Aurora part directly into the AWS console, but I'm just laying out the general terms and a few of the differences. Self-managed are basically something which you download, install, and manage by yourself, or your team manages that. Managed databases are basically databases which is provided as a service, alternatively known as DB as a service. So DBaaS. I will almost always go with DB as a service managed database, in which the control plane is managed by the cloud provider, and I just have a console or a way to connect with the database and just maintain the data. Standby or active setup, TLS, encryption at rest, auto scaling, storage, critical event notification, right sizing, and cost optimization. All of these points become really challenging and really time consuming if you have a self-managed database. You need to go through the documentation, do it one by one. Imagine you need to do it for the MySQL as well as the Postgres. Those are two different databases. You have to understand it entirely differently, go through their own documentation, and then do it that way. If you are instead using the managed database, all of these options are available to you in the console, and you just need to configure it, enable, disable it, and you'll be fine with that. In almost 80% of the time, these things with the configurations, the recommended configurations provided in the managed databases are fine. You need to just worry about the remaining 15 to 20%, or in some cases just 10 to 15% cases where you need some expert help to configure it properly. Migration pattern, when we initially move into the database, something like it comes with a rehosting. So you just lift and shift your database. You take a back of your database. You install MySQL database into the EC2. If any of you are familiar with the Kubernetes, this is basically you can run your databases in container as well, although it is not very recommended, but there are many solutions which run the databases. Which runs the databases in the container as well. So it is the similar pattern. You're rehosting, you are taking the back of your database and you're importing it somewhere else, but you are still doing the heavy lifting. So as an individual or as a team, you are doing the heavy lifting. Managed databases are nothing but a database as a service. RDS, Aurora, DynamoDB, these are all managed databases. They provide the entire infrastructure, all the configuration, everything managed by the AWS, which is called the control plane. And we have the endpoints, we have the necessary tools and way to interact with the database. We just worry about the data part. Cloud native databases are basically re-engineered database. Those are purpose-built, optimized for that particular cloud provider, like DynamoDB, which is only available for the AWS. But MySQL and Postgres are open source databases. You can host it anywhere. Aurora, which is basically a re-engineered solution for the MySQL and Postgres. It is purpose-built again so that it can be highly optimized on AWS. You can use the MySQL and Aurora in RDS, but those are lift and shift. You are just migrating that. If you are using Aurora, the underlying mechanism to use the MySQL and Postgres is entirely changed. We'll come to that in some of the slides. So it's same thing when you interact with that, whether it's MySQL on RDS or MySQL on Aurora, but engineering-wise, it's a two separate thing. Cloud-native databases like the DynamoDB and Aurora are born in the cloud. They are actually meant to run inside the cloud because they are optimized for the cloud. Inbuilt high availability, inbuilt fault tolerance. So Aurora has this self-healing. So if something, it is actually replicates your data in 3 availability zone. If your data is basically lost or AZ is lost, it will internally manage the data, recopy the data in some other place and make sure that your data is still available. And on your whatever disk. DynamoDB, you have like much flexible options to around this area. So these are some of the questions that you need to ask yourself before you start selecting the database. And we want that it is going to be a very, very costly thing to begin with. But if you weigh the other options, if you are building something which is going to be used by maybe hundreds of users or thousands of users, then in most cases, the managed database is a very, very good offering. Better visibility and less ops. That's a control plane part. You are just watching everything. You are taking the right decision based on the metrics and the data insights that is available to you, and you don't need to actually go inside the machine and start tinkering around with the configuration. So first is we'll go with RDS, very popular, like I mentioned, and it supports a variety of underlying engines. So RDS is basically a kind of an umbrella service. When you select an RDS, it gives you multiple options that which kind of database you want to host inside the RDS. It's MySQL, Postgres, MariaDB, MS SQL, Oracle. You can actually host multiple kind of databases inside that. Multi-AZ, you have the failover, auto failover with DNS support with that. Very, very difficult to build this by hand on EC2, although a lot of people do that. But as like I said, I'm not a DBS. I find this kind of task very complicated. If it is not mentioned, almost everything runs in a VPC. So this is basically a VPC based. It's a private database. Both Aurora and RDS are private databases. So it runs inside the VPC. You access to that via the secure way. Although you can actually have the public IP addresses, but it is not recommended to have the public IP addresses to your database in production, because that means anyone can actually point to your database from anywhere in the world. So that is not recommended, and ideally you should always use the database from the public private space. There are some compliant environments in which if you have your database with some kind of public visibility, it will never pass the compliance test. So I have seen it personally with some of the assessments or scrutiny, security scrutiny. If your database has any sort of public access, one or the other way, it will never pass the assessment, and you have to redo or reconfigure it. This size is proportional to your IO throughput. This is basically a very technical thing. In a simple word, it says that how fast you can read and write. It all depends on how much the disk storage for your database that you have given. So something of a 20 GB and something around 200 GB will have a very different performance output. Auto storage scaling, it can go up to 64 terabyte with some increments like 10 GB or 20 GB or whatever increments that you want to configure. You can give the password, which is a very normal way to interact with the database. You create the database username and password and interact, make the connection with that. But you have the IAM-based authentication as well. This actually reduces the security footprints you have. You can minimize the number of users and passwords into your database, and you can manage everything via the IAM. So this is basically a directory or IAM-based configurations to connect with your database. Encryption at rest with KMS. Almost KMS is like integrated into every single service of the AWS. So database being the very critical, very important part of the cloud or your application. So the AMS is available there almost immediately. Auto backup up to 35 days. Point in time recovery. These are very important things. Very hard to achieve if you are doing it by hand manually. Performance insight for the debugging, slow query, some errors you are not able to fully optimize, or at some point of time your database starts performing low. So you need the historical data, which if it is manually set, it is most likely that it is not configured properly if you do not have any DBA experience or if you do not have any DBA in the team. So these are the things. If you are just a developer or a very lean team, no DBA experience, then these things are help. Logging and monitoring is by default available, similar to the CloudWatch. So CloudWatch is similar to KMS, one service which actually connects all of your AWS services together. And if anything, if you want to check anything, you just simply need to go to the CloudWatch. Architecture-wise, it's an instance. We'll actually after this we'll go to the AWS console and start checking everything. Meanwhile, if you have any questions, you can actually start typing it right now. I'll try to answer it when we go inside the AWS console as well. So it's AZ-based. AZ hosts your instances. So you have, like I said, databases in some respect are still monolithic applications. You have the compute and you have your storage at one place. You are storing all your data. You are replicating it. So if any of you are familiar with some of the technical terms of the database, it's called a bean log or transaction logs. That's how they achieve the actually secondary or failover database. So you use the bean log actually to replicate the same transactions onto other databases. So you can actually, if you want to do the low-level engineering, by that you can. It is Aurora is by default auto scalable. So unlike the RDS of 64 TB, Aurora can grow automatically up to 64 TB. So that same scaling option is available with Aurora as well. So here your AZ can be saved, stored into multiple AZ. Your RDS instances can be hosted to multiple AZ. That is a recommended approach for high availability. If something goes wrong into one of your AZ, your other instance in another AZ can take over. Read replicas are mainly used for reading purpose, but if your primary fails, read replica becomes your primary. So that is the silent or transparent switching from the reading to the writing node as well. Again, if any of you are familiar with statefuls or Kubernetes or replica sets, this is similar to that concept where you have the primary responsibility of the instance is to write, but if that fails and if you have the reader instances, then the reader becomes the writer as well. So this is how the RDS console looks like. Very engaging. A few years back, there were very minimum options. Now it is all busy, a lot of options. Aurora being there. Aurora is also very popular among the big enterprises. It is very popular because it has some characteristics which is hard to achieve in the other database solutions. So you will see that there are AWS will keep on marketing the Aurora and will almost always tell you that use Aurora. Even if you go into RDS, it will say that use Aurora. Don't use RDS. Go with Aurora. Although it is costly, it is almost 20% more costlier than RDS. So whenever you are making a choice, if you are starting something, if you are doing something for the testing, if you are just experimenting, make sure you start and stop as soon as your testing is done. Otherwise, it will cost you a lot. One thing I missed, which I say, is that anytime you work with critical services which are going to cost you a lot, like the EC2 instances or the databases which are actually cost basis per second, you start something and you have to pay immediately. You have to start paying immediately. If you are new or if you have never used the budgets, I will recommend that you use the budgets. Excuse me. So you use the budget, set something which is like suitable to you. If you are in the early stage experimenting, or you are just checking out, make sure that you set the budgets according to your preferences, and it will start sending you the notification that something is you are reaching, or you are at some point in your expense. So you don't need to worry about whether something is like already on and you forgot. Just set the budget and then start experimenting with the AWS services, because some of the services can become very costly. You don't want to, and once the bill is generated, you have to pay. Otherwise, AWS will suspend your account if you do not pay. So I'll highly recommend that you set the budgets or the billing alerts right before you start like creating the instances into the database, or large instances even for the EC2. So now we'll go into the create. Here also you'll see that AWS is heavily marketing Aurora as well. You have not said anything. You are onto the RDS console and it still says that go with Aurora. Just plain go with Aurora. It's starting less than $1 a day. It's a very complicated. Billing in cloud is always complicated. That's why there is like a whole domain called FinOps, Cloud FinOps, which is focuses on how you can optimize the billing, how many ways you can be charged, overcharged, how many ways you can actually pay for something even though you are not using. So billing in cloud is very complicated. There are multiple ways to actually do it right, but that will take time. It will take effort and a lot of experience. So this is for AWS to actually show us that okay, it's very cheap, but it is not cheap. It is going to cost you a lot. So we go into the create database option. Here we see two options, standard create and easy create. Easy create, there are a lot of options are pre-built, so we'll not go that. We'll go with a standard create so that I can actually go through all the options one by one. Again, here I have not selected anything. I am actually in the RDS create database. It still selects Aurora as an engine type. So Aurora is considered to be one of the supported engine type of RDS. That's why it will keep coming back. But it is a standalone product as well. So in our case, we'll select the MySQL on RDS. Because it is RDS, so which is using a lot of the community versions and hosting it onto the cloud. So you have the option to select the databases, supported databases based on your requirement. These are the standard MySQL versions, so you can select the one which is suitable to your application or your requirement. So in our case, we are selecting the default 5.7. These are the three options which determines how large or how big or how configured your database will be. So free tier means you are still experimenting. You are actually starting something which is not production ready. You are just want to taste with your database. This will have a very big performance impact as well, because this has a limited CPU budget. So if you are using a very heavy load onto the free tier, it's most likely that you will throttle the CPU and it will have the low performance or performance degradation. Day one test is for the continuous development and testing. Again, it is a different configuration, and production is, we'll see, production is they are recommending that you use a very high configured database for the productions, but production databases means very different thing to different applications, different teams. So I can have a production application which only has a predictable load of, let's say, 100 requests or 1,000 requests or 5,000 requests a day, spread across the 24 hours. So in that case, I will still be fine with free tier, because in that case I'll be able to serve all the database requests in a burstable capacity. So please keep in mind that production is basically different, means different things to different applications. You need to figure it out whether you need something for a high capacity, high frequency database read write, or your load is very minimal to start with. So you should be fine with free tier or even the dev test to begin with. The database name and the credentials, so this will create the default database instance and an access to that. Now, as we have selected the free tier, it will not allow us to go with other options. So just for the sake of illustration, I'll go with a dev test. And here we'll see three different options. One is a standard, which is similar to how we select the EC2 standard M. So you have the T type and you have the M type, which are called general purpose instances. Memory are basically optimized for the databases. These are the instances. It will use the instance which is optimized for the database operations, high read write, in memory calculations and stuff like that. Prajesh, if you can, if I'm audible to others, if you can just disconnect and connect, that should work. So we have variety of options here, and the list, because the RDS knows that this you are hosting a database, it will only show you the relevant options which are optimized for hosting the database. So it is db.r4, and you are not seeing any other options because those are not meant for hosting the DB. Standard options, again, you have the M options, which are general purpose. From the large, which is 2 vCPU to 8 GB of RAM, to 96 vCPU to 384 GB of RAM. It's a very high database, and that's why you see the EBS. So this is basically a throughput. So from 450 Mbps read write capacity to your disk to 14,000 Mbps read write capacity. This changes drastically to if you actually go for different instances. Here, these are actually DB optimized instances. R5 24X large is 96 vCPU with 768 GB of RAM. This machine on which I am currently presenting, it has only 16 GB of RAM, and I think a lot of our machines are just around 16 to 32 to 64. But there are use cases which requires GBs and hundreds of GBs of RAM. But if you select that just for the illustration purpose, it will cost you $9,989 a month. And that is because you have not selected the high availability. If you select a standby instance, that will go to $19,975, almost $20,000. In Indian rupees, this is close to 15-16 lakhs a month. So there are use cases, there are users, there are companies which use these kind of configurations. I have not used it. I'm sure I'm not going to use anytime soon. So I'll be fine with a dev test or even the free tier. We have many customers which are I'm just talking those things from my personal standpoint. We have customers which are using the production databases, but not this large. We have we have few hundred to few $1,000s in a month as a billing, but not this huge. So we'll select the dev test. I'll set the admin 34. 123 as our password. I am test DB. This is my database name, default. You can auto generate as well, but I have provided the password. Memory, I'll use the standard instance, smallest possible. So that is M4 large for this particular example. Number of connection also varies. Yes, very, very important question. We'll come to that as well. Number of connection varies. It all depends on what size of a database instance that you have. This is also true for the EC2 as well. The smaller the EC2, the capacity of handling the connection is directly dependent onto that. The larger the instance, your database has enough resources to actually take new connections. So 1 to 100,000 connections, but it all depends on the instance size. I am starting with general purpose. You have the provision IOPS as well, 1,000. You can go very high as well, up to 30,000 IOPS, and that will also have a direct impact onto your billing part as well. So I'll show you the different calculations in the billing later on. So we are selecting the general purpose. Let's say I don't want a predictable load, and the general access pattern to my database is good enough to start with. So I'm giving the SSD 20 GB. to start with, and here you'll see a very interesting option right away. This is storage auto scaling. That means I have in my long professional career, I have seen multiple times that we have to wake up in the middle of the night or on a weekend, and we realize that the application is down because there is no more storage left onto the instance on which we have actually installed the database. Most recently, I mean 2016-17, we had hosted a Couchbase database onto EC2, and every few months it actually goes down. The application is not responding because the database has no space left, and the only option is to either clear the logs or go into the add additional logs and reconfigure. So it keeps on happening. So these kind of options gives you that feasibility that you can scale your storage when it reaches to a certain threshold. We'll see the notification part as well. So it is not doing that silently. It will notify you as well that the storage is coming to a threshold, and it will add more. So here you can add more. So if let's say I have added my initial disk of just 20 GB, which is not good enough for the database, but let's say I'm fine with that because I know that my data is not going to be very low. So I can actually start with 21 GB. So this is every time it reaches to a certain threshold, it will add another 21 GB into my storage space automatically. Here it scales up to 65 TB. Okay, so this is 64 TB, 64 TB in calculation. So here it automatically can grow up to 64 TB. Standby instance is basically for the failover. If something happens to your primary database, it will silently move to the standby instance. In case of RDS, you have no visibility over your standby instance. It runs silently inside. Only AWS has control plane has the visibility. So you do not see two databases, you see only one database. But if something happens to your one database, it will internally switch over to the next. That happens via the DNS. So DNS is it's in cloud, DNS is everywhere. So you do not access your database via the IP address, you access your database via the domain name. And internally, it is an IP addresses which are changing if something happens. So it runs, like I said, it runs in a VPC. We'll use the default VPC in this particular case. You have the additional configuration options like the subnet, publicly accessible. See, by default, it will always say no. It will not recommend you to have the public IP address, which is directly pointing to your database. In some cases, you may need it for certain things, but it is almost a temporary task. So you do it and then you stop your database. You do not keep it open for the rest of the world to access it as and when required. Okay. So VPC security groups are important. This is, like I mentioned earlier as well, these are the standard fundamental configurations or services of the AWS. So it will keep coming back. Security groups helps you to configure from which all places you can actually connect to your database. So you can do all the rules, configure all the rules here. Password-based authentication, that is your normal database username and password, or you can go with IAM database authentication as well. This actually ties up with your additional IAM permission, which allows you to connect with your database without actually creating an additional user and password. In our case, we set up a password here. So we have the admin as a user and we have password here. There are a few more additional configurations like the initial database name. Now there is one thing which I get a lot of questions when I actually initially explain the RDS to a new customer or new team, that if you have one RDS database, can you host multiple databases? Okay, or in Postgres terminology, can you host multiple schemas? So yes, so RDS will give you a database instance. In that, you can actually create multiple databases by one. This option says that it will create a default database. If you choose to ignore, it will not create a default database and you can actually create your database. But you can host multiple databases onto a single database instance. So all we are creating is a database instance. We are not creating one database. We're creating a database instance and then we are hosting multiple. We can host multiple databases inside it. Enable automatic backup is by default also enabled. retention period, all these things I have spent, I can say that I have spent like hours or days sometimes to configure in some of the previous past applications. Now we just go with managed solutions, so we have all of these things available to us right away. Enable encryptions. If I choose public, you can, so public security, with security group, you cannot actually deny, you can only do the allow. So you can actually, technically you can do some kind of configurations to which you can allow from a specific whitelisted source, but it is basically a specific use case. You can actually allow the source to be either another security group, an IP address, or specific thing, but that is, you have to configure them. In that case, technically, yes, you can have a public IP address, and you can allow only a certain IP address to access that. In that case, that has to be a static IP. See, keep those things into mind as well. That if you are adding an IP, so that IP has to be whitelisted. So that means that IP has to be static all the time. Or if it is changing, like our internet regular ISP, if my IP keeps on changing every few hours or every few days, that means I have to reset that particular rule to connect with my database. For always running, for an elastic IP, so if elastic IP is a term used inside the AWS, so if you have an EC2 instance which is using an elastic IP, that means your EC2 is already part of AWS. In that case, you have no right reason to have a public IP in your database, because it is already, you can already connect to that via private IPs. By static IP, I'm talking about traffic originating from the internet. Elastic IP is basically you can reach to an EC2 instance from the internet. So those are two separate things. Enable encryption. So this is enabling the encryption at rest. Very important, very critical. A lot of the environments, a lot of the applications requires this before you even like write or store your first line of data. So this is by default available, and KMS is like a FIPS level 2, 3, which is considered to be like highest if you are not using the cloud HSM. So you should be fine. With this in many of the compliant norms. We recently actually had one application which had to go with an assessment, and database one of the critical part, and KMS saved their day, because these are the solutions. If you just mentioned that it is using the KMS to store, encrypt the data at rest, you are basically passing the assessment. Performance insights for debugging, monitoring, enhanced monitoring is also enabled. I'm not going to enable it. You have the log export. These are the things. I don't know how I have done this in past by hand, but I have done it with a lot of Googling and configuring it. Here we just need to enable it, and all of this is available in the CloudWatch, easy to use. And with CloudWatch, you can actually stream the data to EC2 or Lambda or other place, so you can actually have continuous real-time feedback if you want to build that kind of system. Maintenance window is basically for the AWS to patching, because this is basically database as a service, so control plane is not available. We cannot access the instance directly. So if the AWS wants to install a patches, a new security update, this is the window for them. So we need to, usually this is given some midnight, maybe on Saturday night or on Sunday night, but it all depends on the usage pattern of your application. For some applications, the weekends are very popular, like the gaming applications or e-commerce applications, and Mondays are preferred day. Monday nights there is a low traffic, Tuesday night low traffic, but on weekend there is high traffic throughout the night. So depending on your application, you can actually configure your preferred maintenance window. Deletion protections is just to ensure that nobody, because Edge is a separate, high, very big topic in itself, that how your ops, how your DevOps part should be set. So if you have multiple users who are configured to use your AWS account, you want to make sure that your databases are not accidentally deleted by someone manually or by some automation tools like CloudFormations or Terraform or stuff like that. Here we are coming to the cost part. So it is multiple. In cloud, everything is, like I mentioned, it is separate. So DB instance is basically your compute node. It is costing us $189 USD per month. Storage is very minimal. Storage in cloud is very cheap. Storage is always going to be a very cheap option. compared to the compute. So it is 2.76, and plus we have only given the 20 GB, so it's not that bad. Multi-AZ, that means there is another instance which is silently running. So every time you see a multi-AZ instance or a multi-AZ or a high available database or high available service, it always means that there is a duplicate, there is a secondary service running. And that service is not going to come free. So that means you have to pay the same which you are paying for the primary service. So in that case, that's why it became 189 again added. So what I'll do is I'll actually disable that. I do not need the secondary service. Do not need a standby instance. We have few production solutions which are very low load and predictable performance. They are using the single, which works just fine. So you will have many of the use cases in which you do not need the secondary thing. If you have the backups available properly, and if you have the RTO, which has a general recovery point and recovery time objectives. So if you have those like very casual, then you should be fine with backup recovery based solution as well. Read replica is basically you are creating another instance which is meant for your read load. So every instance you have to pay. If it is the same instance size, then you have to just multiply that by the number of instances you are running. So if it is 189, if you add one more read replica, then it is 189 twice. If you add two read replicas, then you have the primary 189 and then you two read replicas. So that is you are paying 189 3 times, plus the storage cost, plus the data transfer, plus the backup and all those things which you are storing as well. So there is a lot of calculations when it comes to the costing. So now we'll create the database. The biggest difference that we'll see in the output or the configurations between the database of the RDS and database of Aurora here. Here it is creating individual databases. So we are managing one database at a time. In Aurora, it is basically creating a cluster. So replica set or a cluster of databases, or if any of you are familiar with Hadoop, some of the concepts from the Aurora are taken from the Hadoop itself, which is basically a compute nodes sitting on top of the storage nodes. It uses all your query, a big data solution or data warehousing solutions, all are same. So which is basically nothing but a cluster of nodes which are internally managing your compute, your query, and your storage. What exactly we use Red Replica? So there are, let's say you have a Myntra-like application, which is using a large catalog of products, and I can say that 80% of the load onto the database is basically viewing the data. So that means viewing the catalog. You have a lot of items. You have thousands and thousands of items which you are reading from the database. And out of that, you have, if Myntra has a conversion rate every time someone visits their site, if they have a conversion rate, that is basically a commercial conversion. So every time you purchase, that goes into the update mode as well. So every time you make a modification into your profile, every time you purchase something, that becomes a writing part. So your writing is low, but your reading is very high. And you want to split this traffic between multiple instances. So you want to make sure that your application is very responsive. Even though you're using the relational database, it is still responsive. So you want to split the traffic of reading and writing separately. In that case, you use the reader instances where only the read queries, select queries only goes to the read replicas. All your DML, so data manipulation statements like the create or update or delete statements go to the primary node, which is capable of writing. The reader node is only capable of making the select queries, not anything else. It is by default not allowed. It will actually throw an error if you are firing the DML queries onto the read node. But in some cases, that's a very good question. So that's why the database engineering underneath is a very complicated. I can say very confidently that Aurora is basically an effort of years or decade of engineering, re-engineering If any of you are familiar, you can actually search for the term called bean log or transaction log. That's how multiple solutions which are capable of creating the synchronized multiple databases. Even in the RDS also, it uses a bean log, a kind of a secondary transaction log technique, where if something happens to your something changes in your primary database, it will generate a ledger. You can write, or you have the program, you have the tooling which actually continuously listens to the ledger entries, and it will actually send those ledger entries to another database. So practically you can actually send it anywhere across the world. That's how they achieve the across the AZ, across the region replicas, because you are transmitting those ledger entries and you are rerunning those ledger entries into that database. So that's how you are actually synchronizing the databases which are spread across the world by just writing into the master node. That's why primary is always one. You have one primary node in which you write, and you can have many read nodes, because by that way you are transmitting the ledgers to multiple places and rerunning it so that you are synchronizing the data. There is always a lag, there is always a latency. It all depends on where you are transmitting, how far the another instance is. Is it just across another AZ in the same region, or is it across another region? Because in that case, you are actually adding more latency. So there is always an inconsistency. There is always some additional latency when you are talking about read replicas which are spread across AZs or regions. I hope that answers the question. It's a very interesting thing. Database has undergone a huge re-engineering. So in this case, our database is ready to use. As you just select the database, you will see multiple options. Current activity, no sessions. You can see a lot of these things in hand. Monitoring, it will start giving you some kind of data after a few minutes. So IOPS, freeable memory, free storage, CPU, DB connections. Very interesting, very important thing to have this kind of detail upfront without configuring any additional tools or any other additional applications on top of your hosted databases. Events, you can actually cloud, whether it's AWS has a better way to actually organize and show the eventing. So I'm always I have most of the information available to me, and they are actually enhancing their UI. This is a pretty good UI. Few years back it was horrible, it was like 90s application few years back, but now they are actually also changing the UI as well, so you can see a lot of internal detail, a lot of insights right there. From your configuration, you can see that encryption is enabled. It's KMS based, RAM, 8 versions, options group. If any of you have done the on top of database additions, like installing the Memcached or some other solutions which are tightly integrated with your particular database, like MySQL supports the add-on Memcached BA solution as well. So those can be configured with option group. And there is a parameter group as well, to which you can actually configure your database options specific to your database instance. Those are just the variables that we set inside the MySQL or Postgres. Deletion protections, maximum rate. Now we'll try to actually connect it. So what I'll do is, I'll take this is my endpoint. So endpoint always means a place where you connect with that. It has created, it has used the security group which I have already available in that VPC. So we can see the VPC as well. I'm using the default VPC. Every region, if you are new to AWS, every region has a default VPC. It has a few subnets and routing and security groups configured in that. So I have multiple VPC. I'm using the one which is default. I can show the security group as well. So this is one. Sorry. So this one is, let's say it is 836E. So this is the database. By default, it is an internal, so it allows all the traffic from the same security group. So source is same. It allows all. So it internally allows all the communication. So what we'll do is, now we'll go to one of the EC2 instance that I have already. So that is DB2 instance. It's a vanilla instance, P2 micro, nothing inside that. So I will just try to connect our database from that. I hope my screen is still visible. SSH. To I'm inside. I have MySQL, but this is a local MySQL, so I want to connect to MySQL, which is hosted onto my RDS. This is my RDS. This is the endpoint that I have. Okay. I'm inside that. So this has all the default database inside it. You can actually check a few things. It will show some spike. It will, after a while, it will show the connections and sessions as well. So you can actually start checking those things. Very good level of detail is already available, and this is because we have not enabled the detail enhanced monitoring. This will come after a few minutes of a few seconds of gap. This is that. Now, two important things which actually usually always required. One is a parameter group. So these are the places usually when we want to configure your database certain way, you need to go inside the data. You go inside the database and run the SQL statement to actually configure the variables. But you can actually do all of those things from outside here. Like let's say I want to check the TLS version. So this is the version that it supports. Then I want to make sure that the connections are only using the SSL and not the plain connection. So I can actually configure it from here. That requires secure transport. I can enable it, edit the parameter from here and apply the changes. So I don't need to go inside the database. And one of the reasons I have actually kept the database private. So if I need to access the database from my machine, I cannot do that directly without installing the SSH terminal on EC2, or I have to just go inside the EC2 and then connect to the database from there. So these are called the jump boxes or bastion hosts in some terminology. If you have clear any of the AWS certification, this term comes, because that means you are not accessing the assets, private assets from your machine directly. You are first logging inside the AWS environment via the EC2, and then from that instance, you are actually connecting the database. So in that case, this one works. Now this is the plain string. This is the connection string that you use with your application as well. So there is no change, there is no difference. And in a lot of sense, the RDS is nothing but your same as your EC2 hosted MySQL. The only thing is, in this case, it is hosted and managed by the AWS and not by you. So what I'm going to do is I'm keep it running. I'm going to go into the next step. Any questions so far, I will be happy to answer. Let me see. This is costly, but I'll come to the cost part. I'm sure a lot of you have seen that it is costing me $189 a month, which I do not, even I'm not going to pay if I'm starting something without EC2. You can connect to RDS without EC2, but in that case, you have to have a public IP. So that particular domain name, that the endpoint that we connected with, that's basically a private endpoint. This one is a private endpoint which is only available inside your VPC environment. It is not going to resolve outside. The other option is you have to actually make your database publicly visible and then connect to that, which is actually not a recommended approach, although there are many applications which actually use the external databases. Like let's say the MongoDB has their own cloud, so MongoDB is a cloud. So wherein if you are hosting the database onto the MongoDB, you want to actually connect, and your application is running on AWS or Google Cloud, you want to connect it from there. But there are always some kind of additional security measures, whitelisting, the TLS, SSL TLS connections through which you use the database, not direct. So you can do that, but it is not recommended. So that is that. Now coming to the cost part, so this is I always have that question too, that it is very costly and we should look for an alternative. One alternative is that we can go with EC2. In that case, you are paying just an EC2 specific pricing, but rest of the things you have to configure. So those are the man hours. So then you have to start putting the cost of the man hours, which usually no estimates put when it comes to the administrative tasks, because those are considered to be silent tasks. Only the development and other tasks we have put into the estimation and not the silent part. So in this case, the DigitalOcean has something a similar offering. So DigitalOcean started with a vanilla cloud where you have the virtual machines you can host. We have many applications which are still hosted onto the DigitalOcean. We have the databases, MySQL databases, which are into the production for past almost 4 years. We are using the virtual machines in DigitalOceans with hosted MySQL. So those are basically by hand configured, but they have the database as a service as well. If you see the costing wise, the similar configurations, 2 GB, 2 VCP, 4 GB is also roughly the same, not exactly the same, but doing the other calculations, it comes more or less near to that. So DigitalOcean is another cloud. So there are many cloud providers. AWS is one, DigitalOcean is another. DigitalOcean in some cases are much cheaper if you are just going for a compute. You want a virtual machine to host your application, you can use that. It is not basically, it does not have extensive services like the top tier cloud providers are, like AWS, Azure, Google Cloud, and now Alibaba and Oracle, but it is still a very good alternative if you are hosting some applications. So next we'll jump on to, and there are, so I have one slide related to how to optimize the billing part. So wherein which these are the prices that we are paying on demand. So that means you are actually paying by second. If you know that your application will be running for 1 year or 3 years, you have multiple options like reserved instances. You have the savings plan for predictable billing purpose. So if you go, for an example, if you go, let's say I'm into RDS right now, and what I'll do is I'll go to the reserved instances. So these are basically you are committing to the AWS that you are going to use this particular configuration of the database for next 1 year or 3 years. So I'm going to purchase a reserve. I'm going to reserve a DB instance. So this is not on demand. I'm telling the AWS upfront that I'm going to use this $189 a month instance for next 3 years. Okay. So let's say I'm selecting MySQL. Same configurations I'm selecting for large. So it has multi-age, no, it has no multi-age. I'm going with a 3-year term. So I know that my application is going to run for next 3 years at least. I'm open to pay everything upfront. So that is I'm ready to pay all the cost which is had for upfront. Now this will come to $25 and $2,541 USD for next 3 years. So if I divide it by 36, I'm actually paying $70 a month, which in this case, if I pay on demand price, I'm actually paying $189 a month. So these are some of the options which a lot of new teams which are migrating to the AWS, they do not start. They know that their applications will be at least running for a year. Still, they do not actually look for that. If you are running your applications for a year, it will cost you a little over $100. If you do not use this, then actually you are paying $190. So there is a huge, there are a variety of options. Besides the reserve option, you have the variable pricing, you have savings plans as well to optimize your cost further. This requires some kind of experience, some time and effort to make sure that you have you analyze your configurations and then purchase the instances, because once you have committed, you cannot go back. You have paid. You can actually decide for all upfront or partial upfront. Once you have paid, you have paid. You have to just forgo the payment part. and now I have to move. So reserved instance is basically a secondary thing, so you can purchase it anytime. On demand is something you are being charged on per second, per hour basis. So if I purchase a reserve instance after few days of running it, so it will start applying the reserve pricing from that day onward. It will actually apply the reserve pricing as soon as you purchase it. So it is not that something you have to do before you create your database, you can do it after as well. So now we are running late. So I will go into the Aurora part. So next option is Aurora. Some of the concepts remain similar. Aurora is basically a re-engineered database solution. It is only compatible with MySQL, Postgres at the moment. It is cloud native database. That means you cannot actually, there is no Aurora offering available to download and install. It is meant for so reserve instance, you already have a side menu. So if you go to the RDS, you can actually go reserved instances. Okay, here you can purchase a reserved instance. Just take a couple of minutes, so I'll go through the steps. I'll not purchase because once I purchase, I have to live with that. So I'll not click on the purchase option. So purchase the reserved instance. I have to select the engine type which is applicable to my database. So because we have created the RDS, I'll select the RDS MySQL. So there are Aurora MySQL and Aurora Postgres as well. You have to carefully select. Whenever you are doing any of the reserve purchasing, make sure that you thoroughly check all the configurations because it cannot be rolled back. You have to just use that configuration or you have to forgo the payment. So there are concept of slicing, but I'm not sure whether it is applicable to the database. It is applicable to the EC2 for sure. So I'm selecting M4 large. I'm selecting no. 1 year term or 3 year term. I can select all upfront. If these are optional, this is basically if you have some kind of a tag to attach with that. The number of instances, how many reserve instances you want to purchase. So this is for one instance for next 3 years, you are paying upfront $2,541. You can actually continue from here and complete the payment. This is all right there. And before you hit the payment, just make sure that you have all the options, configurations properly checked. It is not launching. You are actually purchasing the reserved instance. You are just telling the AWS that you want to occupy or you want to actually reserve the capacity for this instance. This is just, it is not going to create an instance. You still need to go to the RDS and create the instance. This is just applicable to your billing. It's like basically a credit or you have a voucher. So you have actually paid AWS an upfront amount, or you have also committed an AWS that you are going to use this much configuration of a machine for next 1 year or 3 years, and you are paying it partial or full upfront right now, and then you go and create an amount. Or in some cases, if you have already created the databases, you just say that okay, from now on, I want to actually purchase a voucher. So it's you can analogous to a voucher. You are purchasing the voucher, and then your AWS will start adjusting the reserve, all the reserve purchases that you have done with your actual billing at the end of the month. Okay, great. So now we go to the RDS again, and this time we'll create. What I'll do is I'll stop this. This way. No. Stopping the, you can stop the instances, in which case you will actually a lot of the billing will not happen because there is no compute or anything running. But if you have a provision IOPS, you will still be billed for that. If you have large storage, you will still be billed for the storage. So stopping and deleting are two separate things. If you are not going to use this for next few weeks to few months, I would suggest create a snapshot and delete the database. You can actually recreate the database from the snapshots anytime you want. It will save all the snapshots, manual snapshots forever. But if you are going to use it after some time, snapshots are also charged. All the storage is charged, but storage is very cheap in the cloud, and storage is basically based on your actual consumption. So if you have a 20 GB of a database which you have created, but you have only used 1 GB, your snapshot is of only 1 GB in size. It's basically, there is nothing else to store. So it will only store the data, the data, not the actual storage capacity which you have allocated. So we are stopping that. Starting in this time, we are actually going with Aurora. So I am going to select MySQL. There are Aurora, when you go into the Aurora, they keep on adding new features. You have many more features as well. One of the very popular, the very interesting feature is coming to that bean log, and the database underlying engineering concept is regional and global databases. You can actually create one database which you can use from all over the world. Okay, depending on how many regions you have selected. Those region, those actually secondary global databases are read only because it will only transfer the read part. The write will still happens into your primary region. So in our case, the primary region is Singapore. I can actually choose to host a secondary Aurora database in the Mumbai. I can select it Hong Kong or any other places. Those are basically will become the read databases, and my primary, the place where I can write is still going to be the Singapore region. I'm going to select go with regional only. One writer and multiple readers. Again, terminology wise, this will now go into the cluster based databases or big data or data warehouse based things. So if you are familiar with some of those terminologies, it will be easy to start with. Serverless is it's very interesting new thing. We'll go into that very end. Production and day one. Now Aurora is costly, so even if you go with production, the size are also very big. So the smallest size that you have available is 2 vCPU with 15 GB of RAM. Okay, that is almost 16 GB of RAM that you can start with, and the largest is same 96 vCPU to 768. We are not going to create the Aurora. So here you have the burstable and the memory optimized. For dev test, you can actually have the smaller instances, but other than that, there is no secondary configurations. So this is 16 gig of RAM. I'm going to R5. But T3 has a burstable capacity, so even if you actually exhaust all your CPU credits, it will actually go on and continue. It will not throttle your any of the queries or anything. You will have to pay for the additional CPU credits that you have used, but other than that, your database part will work. Most of the other cases, when it comes to the limits or the credit based, burstable based, if you hit the limit, it will actually start throwing the error. It will not allow you to read or write anything unless you you go into the next time slot. So how, if example wise I need to tell, so every instance that you actually register into the cloud, you are selecting the instance based on your requirement. So the larger the instance, the more credit it has. That means how much of a CPU time you can use in a given time period. So in a second, in a minute, in an hour, likewise. So if you go with the smallest, it has the lowest CPU credits available, because those are basically like low usage, unpredictable loads, and that's why it gives you the smallest possible slice of CPU to use, which is fine for a random usage throughout the day, because it will recover. It will the credits come back as time passes. So, but if you want to do a lot of heavy read-write operation in a small amount of time, that means you are filing a lot of queries in seconds or in a minute, then those small instances will not work. Then you have to go with larger instances, because which has larger credits. Similar to the provisioned IO. So if you want to do a lot of read-write to your disk, you have to purchase the IO operations. Otherwise, the normal IO operations will actually start hitting the limit depending on your storage disk size. So it is the same. The T3 is basically a burstable, so it can extend your burst capacity as well. So let's say you have utilized all your CPU cycles in a given time frame. You used for half an hour and you utilized all the CPU cycles for your operations, which usually you do not. but on one given day you utilize all, but you still want to continue using that. So what it will do is it will not throttle, so it will not throwing the error. It will still allow all the operations to go, but it will charge those things as an additional CPU cycles. So in your billing, you will see that there are additional CPU credits which you have used, and you have to pay extra for that. Otherwise, whatever is the normal per second per hour cost of that instance, you have to pay that. But if you are actually going above the CPU credits, you have to also pay for the CPU credits as well. I hope that we read right. We go for burstable for addition CPU cycle. So CPU cycle has a dependency on the instance size as well. Heavy read write is directly proportionally related to your disk as well. So if you are using a 20 GB disk, you still have the capacity of how much read and write from the disk you can do. I'm talking about the CPU cycles. For one is so database is divided into two parts: compute node, which actually does the query projections and execution and all those things, and read write, which is coming from the disk. So IOPS is dependent onto the disk, and CPU credits are dependent onto the compute. So those are two separate things. And just for the example purpose, I use the example of IOPS. Don't create Aurora replica. You can create the reader nodes in separate availability zone. I'll keep all the other things as it is. No public access, existing, no preference, additional configurations. We have the database on my test. No initial database. I'm using 5.6 because I have selected 5.6. There are very limited options when it comes to the Aurora selection as well. So there are the few of those compatibility wise. And please be aware that whenever you are using the Aurora, it's compatible. So this is not exactly your soft MySQL or Postgres. This is compatible with that particular version of MySQL. So feature-wise, if you are doing heavy migration from your existing MySQL particular version to Aurora, you have to actually do like a homework. There are few tools available inside the database as well, like the schema conversions or the DNS migrations, which allows you to detect changes you are migrating from the any database, MySQL or Postgres to Aurora. It will actually do the assessment and tell you that what are the possibility that everything will work properly or not. So you can look into those tools as well. Rest of the options are still same. Backtracking is very interesting, like recovery, but like recovery, you can actually backtrack up to 72 hours. But this is a costly feature. If you start with 1 hour, and if you go to 72 hours, you add additional time. If you want to make sure that you can recover any time you want in last 24 hours, then you are actually paying extra to maintain those additional data for the recovery purpose as well. So I'm not going to enable that, but it's a very interesting feature. These are some of the features are possible only because it is re-engineered to adjust to the cloud environment. Otherwise, in a normal database, it will be very difficult to maintain these things. And we'll go with just. We have all the options. Most of the options are similar to the RDS. There are some additional options which we have done. Other than that, it is I'm not actually enabling that as well. Yes. And we'll go into the create database. So it has started creating one. So Aurora is not internally using MySQL. Aurora has two internal flavors. One is MySQL and one is Postgres. So you can actually create Aurora for Postgres, and you can create Aurora for MySQL. It is only compatible. It has only two compatible databases at the moment. The biggest difference that we see between the RDS and okay, it is still deleting. I'll create another database. We'll give it a different name. So I'll go with create this time. You can actually easily create that as well. Database 2. Mm. These are all the options that it has applied, similar to what we have applied. Database location is regional, database feature is provision, encryption is enabled, not. VPC, it is inside the VPC. Editable after database, it's the important things. In some cases, you want to pay attention to that. Some of the things you cannot configure post creating the instance. Only option then will be take the backup, destroy this, and create a new one. Yes, that is right, Jatin. And I'm going to create. So the first thing that you start seeing that it actually uses a different way to represent the Aurora and RDS. RDS is basically one instance at a time. Even though you have read replicas, those are isolated individual instances. Aurora is always a cluster. It is one cluster inside which you are creating the reader and the writer and the read replicas as a node, additional nodes. So you will see this as a different demarcation, that it is creating a cluster, and inside that it is creating an instance. So this is a cluster. This is my cluster endpoint. I'll come to that part as well while it is creating. So structurally, this is how your Aurora looks. So this is how your RDS looks. Those are full monolithic applications, compute and database. Everything goes together. So if you want to replicate the database, it is done via the transaction logs or the bean logs. In case of Aurora, it is re-engineered, so it is created differently based on the huge amount of experience that Amazon has, almost 20 years of experience that Amazon has by maintaining some of the largest databases in the world. So what they do is they use a same storage subsystem. So this is called a distributed storage subsystem. Your database is detached with your storage part. This is the same concept as well, big data, other big data platforms as well. Your storage is entirely isolated. And all you are doing on top of that is basically adding the compute nodes, which helps you to actually execute the queries. So every time you receive a write request, it actually receives to an instance and it forwards that to your cluster storage, and it will write into that. Now your cluster storage is, you can say, for the example purpose, you can consider that as like a shared drive, network drive. If you are adding more instances, then it is just attaching to the same storage mechanism. Now, the biggest difference you will see here is if you create a new RAID replica of an RDS instance, and if it has, like, let's say 100 GB of data already, it will take big amount of time because you are replicating the entire database and then creating another database which has its own disk, its own data, and its own compute. If you are doing the same thing with Aurora, what it does is it only adds an additional compute capacity because the underlying storage is same. You are attaching to an existing underlying storage system which is used across all the different compute nodes. So whenever you are adding a new replica, you are just adding the compute nodes. The data part is still there as it is. So it takes much less time. It comes up fast if you are adding new nodes in Aurora compared to the RDS. And that explains why keeping the database or keeping the storage part separate to achieve this kind of flexibility. So it is available now. It is creating the instance. So instance has its own endpoint, which is called instance endpoint. Cluster has its own endpoint, which is called cluster endpoint. And then cluster has two endpoints. One is for the reading purpose and one is for writing purpose. This is helpful if you have multiple instances inside a cluster. So this is all if you are coming from the big data or Hadoop or replica set or even from Kubernetes, stateful set, those kind of domain, then you will be able to relate this much better, faster, that there are separate endpoints to point to a particular set of nodes. We'll let it create. So there are 4 endpoints available in the Aurora. In case of RDS, you have one endpoint. Your your DNS name is directly pointing to an instance. In case of Aurora, you have total 4. You have the cluster endpoint, which is pointing to your entire cluster, and internally it will actually divide the load if you have multiple nodes. Your reader endpoint, which will only redirect the select queries to the reader instances. It will not actually redirect the reader query or the select query to the primary instance, because primary instance is meant for the writing purpose. So all your email statements will go to the primary, and all your select statements will go to the reader nodes. This is, let's say you have a reporting application which just queries the data, or there are large queries, or there are some things which you just want to set aside and away from, split from your normal operational load, you can actually use the reader endpoints. Now, custom endpoint is very interesting because Aurora is very flexible. It is very large. It can actually support a very large, complicated query and environment as well. So a lot of the data warehousing, a lot of the reporting logic directly runs on the Aurora itself. That means your query can go complex as well. So let's say your primary nodes are sufficient with 16 GB of RAM, or maybe you have the medium size 64 GB of RAM, but you are filing some queries which is very intensive. It is running on a lot of data, and in that case 64 GB is not enough, and you want to go with 128 or maybe 256 or a very custom high-end instance just to fire those queries. So custom endpoint is meant for that, where you can actually group those dedicated instances together for your specific application or for your specific requirement. So that is very interesting, a very highly useful application, highly like a useful feature. We'll see one of the slide which has how the Zendesk and the Autodesk are using these kind of features to actually run queries on millions of records at a time. And the instance endpoint is basically nothing but a direct endpoint which is pointing you to your one particular instance. So you have total 4 different type of endpoints available in Aurora. So this is how the endpoint mechanism works. So your application has the cluster endpoint, and your application has the reader endpoint. It can actually redirect all the reading queries to one. And this is actually the new normal when it comes to the microservices. In the orthodox application or the old applications, we have only one like a connection pooling, or one service which manages all the connections. So it has only one URL string, okay, and it is pointing to that. But when it comes to the microservices or Kubernetes, where you have multiple services running separately, you can actually pass the configurations which are most suitable to that service. So if you know that there are certain services which are just capable of just meant for the reporting and the query purpose, you can pass the reader endpoint instead of the primary endpoint. Internally, it's the same. Can we redirect endpoints based on our requirements? Yes, you can actually create a new endpoint as per your requirement. That is available from here. You can actually add a reader and then create a custom endpoint as well. So this will, if you have more instances, you can actually point to this with a custom endpoint name. You can actually give your name based on the service name and other things as well. And right now we have only one instance which is doing the writer and the reader both parts. We are seeing only one. If you add more read replicas or more instances, you will start seeing it here, and from there you can create a custom endpoint. And you start appearing here as well. So that is the demo part we have already covered. The connection wise, it will work the same way that we have right now. What we'll do is we'll go through that as well. Edge. Okay. For your normal operations, it doesn't matter because that endpoint is nothing but it fits into your URL string, your database URL string. So that is under regular connection string. but internally it behaves differently depending on which kind of endpoint it is. Whether it's a cluster, so it is pointing to the root and then diverting the request from there. If it is reader, then it is just pointing to the reader nodes. If it is custom, then it will just point to that. You can have up to 15 read replicas inside the Auroras, and if you are then choosing the global, then you can actually further expand that. There are many use cases, there are many companies who actually go with a lot of additional replicas as well if their load, their application is actually divided or spread across multiple regions. Can I connect my DB to any SQL AMI created inside EC2? I don't understand the question. So can I connect my DB to any SQL AMI created inside? Yes, you can. Basically, in that case, you are not connecting to the DB, you are connecting to the EC2 in which you have the database hosted. So as long as you have the ports are configured properly, security group configured properly, it's basically the same. Here also, see, this is the same thing. So two endpoints are already created. One is a cluster, and one is there are basically three endpoints which are by default available. One is a cluster, which is pointing to the writer node. One is a reader. This is also by default created. And third one is your instance. You will have always one at least instance in your cluster. So that is your third endpoint instance. So we have total 4. So besides the custom, you have the cluster, reader, and instance by default available. If I want to create a custom, I can still create by selecting one of the instance. So if I go here, create a custom, and my DB, and I select this, so it will create a fourth one. So 3 are by default created because that is how the cluster works normally. So everything that is attached to the cluster, it is already available. Custom is for your custom requirement. So now we have 3. So 1 I have created and 2 are automatically created. So that's why I cannot delete or I cannot modify or do anything. AWS. So there are few case studies available as well. I have put the links here. I'll put some more links. But Aurora is basically meant for a very heavy requirement, and to almost everyone, to all of my customers also, when we go with Aurora or when we go into that kind of discussion, I always say that let's assess the requirements right. Because Aurora can become very costly as well. If we have a very moderate or predictable load, it might be like abusing the resources, costly resources for not very broad purposes. If you are not going for the readers, if you are not going for the additional replicas, if you are just using, if we just need a highly available database, then the RDS will just work fine. So that is my suggestion to all of you as well. Whenever you are going into that kind of consideration that you want to use Aurora, make sure you assess your requirement, do the due diligence with RDS as well. In many of the cases, RDS will work just fine. Look at the numbers here. Zendesk is actually storing and processing the tickets, customer tickets at a very rapid rate. And these are millions of records they have actually, and they are using one of their internal tool like Zendesk Export to process through this customer tickets, 60 million customer tickets to create the custom views inside the Explore, which was previously basically a startup which they acquired a few years back. So these are very, very stringent, very complicated requirements, and for that, the Aurora is the best fit. That's why enterprises go with Aurora very fast because they can fully utilize the power of Aurora. For a small startups, for even for the development, it's good for the learning and development purpose. But otherwise, it will for us there will be no good use of Aurora to start. Autodesk is a very popular. They have actually showcased this into reInvent as well. How AutoCAD migrated that huge SSO basically queries, and that too because of the huge number. They had a very dedicated session as well. And there is a detailed blog post as well. 142 million user response to over 145,000 API requests per minute. And that all happens over Aurora. It's a very high and critical and Autodesk, we can assume that they have like millions of users and they want, without login, none of their aggregated services work. So this is a very critical service which they migrated Previously, they were hosting it on EC2, and then they migrated to MySQL. So there is always a point comes in which people or companies migrate from one solution, their existing solution, to a next one to achieve the higher flexibility. Now comes the last part. We are to the time. I think, but we'll be able to catch up. So far, so good. If any of the questions related to the relational databases around the RDS and Aurora, please ask right now. I'll try to answer it as much as I can right now, and then we'll go into the DynamoDB. Okay, what I'll do is I'll stop this. Okay, I'll have to actually delete. So DynamoDB is the similar to the RDS, which is a relational database. DynamoDB is a NoSQL database, extremely popular. DynamoDB was created to manage the growing basically rate of Amazon.com in early 2000. It was they were actually rapidly expanding, and Amazon was getting huge popularity across and usage. So they didn't have, they were their servers, their existing solution was working on the Oracle at that time, and it was not matching up with the capacity and the kind of the load and the demand they had. So they decided to write their own database to support Amazon.com. So Amazon.com is the, like I can say that the first customer and still a very heavy customer of the DynamoDB itself. And DynamoDB is a NoSQL key value pair database. It's cloud native. So it is not actually, it is available to download locally and run, but it is just for the development and testing purpose. It is not, you will not be able to utilize the true power of the DynamoDB on your local. It is practically not possible. So it's basically a cloud native database, born in the cloud, meant for the cloud. It's also a serverless database. So on coming to the RDS and Aurora part, if you just started a cluster or just started an instance, if you do not use it, you still pay for the provision because you have provisioned the compute part. You have provisioned the compute, you have provisioned the storage and everything. So you are still paying, even though you are not using, you have to pay that $189 or whatever cost that is showing, you still have to pay even though you have not firing a single query. But in case of DynamoDB, it is entirely different. The reason why it is called serverless database is that it is charged based on the consumption. So every time you use the DynamoDB, you have to pay for the actual usage. That is the overall fundamental concept of the serverless itself, that you pay by the consumptions, you pay by the execution. So in DynamoDB, the cost is based on the storage and based on the queries that you are doing. And queries are divided into two parts. It is terminology-wise, it is called the read and the write capacities. You can set the predefined read and write capacity for the higher throughput, or you can go with on-demand, which was introduced a couple of years back. So it is very flexible option. So I almost 99% of the time, when someone asks me that they want to use a database, I tell them that see if the DynamoDB is the best fit for your application, because in most of the cases you will be fine with NoSQL database if you do not have very structured or very like dependency onto ERD, that is entity relationship, or a relational database if you need for a transaction. Even DynamoDB does support the transactions part, but if you are not very reliant onto the RDS or a relational database part, then you can actually use DynamoDB for all of the requirements. There are use cases which use the DynamoDB in the financial, healthcare, gaming, ad tech, even the Snapchat. I have one slide on that. Probably I'll add that later. So every kind of use case can be supported by DynamoDB. Even Amazon.com still uses DynamoDB heavily. No storage provisioning is required. In RDS Aurora cases, we are giving some kind of a predefined storage configuration. In case of DynamoDB, it scales automatically. We don't need to actually provide anything that how much of data will store. We have some DynamoDB tables which we have created a couple of years back. They are still there. There is no usage of the application, so we are not paying anything. So there is no cost attached to that if you are not using it. Again, it's a relative term, so you have to set few things. If you have provisioned the capacity, that means you will be charged for the provision. But if you are using the on-demand, you will not charge. You can download the DynamoDB local for development and testing purpose, so you are not continuously using the DynamoDB in the cloud. Structure-wise, it is slightly different. If any of you have ever worked with the MongoDB or key value paired databases, it is very similar to that. You have a partition key. In DynamoDB, it is called the partition key and the sort key, which is how it actually distributes the storage and achieves the higher throughput and operational capacities. So you have two things. One is a partition key, through which your data will be divided across multiple partitions. Inside that, you can have the additional sort key as well. So that is the additional secondary field there which you want to attach. In RDS term, it is called basically a composite key. So you have a primary key, you have the secondary key. You have multiple keys which creates a primary key. We have multiple fields which creates a primary field. So key value access pattern determines data distribution, how your data, where your data will be stored. It internally, it learns, it actually spreads the data across multiple partitions. Every partition is basically 10 GB in size. You have the table, you have the different fields. Fields can be variable, as you can see from this small image. First record has 5 fields, the second has only 1, the third one has 3, and the fourth one has only 4. So that is a variable field. That's why it is called key value. Your every record, your every document will have a different variable number of key. How it does is whenever you actually store something, it first calculates the hash. The hash will help it to identify the partition, whether it will store in one of the existing partition or whether it will create a new partition and store in that. And then it will go inside that and store it there. Analogy wise, if you have familiar with the old hard disk, so old hard disk has the magnetic disk. So those are magnetic plates inside that. And you have a head, small head, which actually moves between those plates, and the entire metadata of what data is stored where is basically part of the file system indexing. So whenever you are reading one file, it will first check on which disk you need to go, and on that disk which seek you need to make. So at which point you need to go. So similar to that, but DynamoDB by default uses SSD. So it internally creates a partition, and then inside that partition, it stores the data in a particular format. You have, this is very recently announced. So for most of the databases, you have some kind of editor or some kind of tool, interactive tool available to actually interact with that, like MySQL Workbench, or you have the DBWork, or you have many other things. For DynamoDB, they have recently released the NoSQL Workbench, which is very good. You can do a lot of things, because my DynamoDB, even though it looks very simple, it can go extremely complicated. So this kind of tool helps. Like I said, serverless backend, mobile applications, any kind of use cases where you do not want to provision, you want to pay only for what you use. You want to start small, but you want to also grow as much as you want. So for all those kind of requirements, you can actually go with DynamoDB. Interestingly, there is one thing. So if you want to load large amount of existing data into DynamoDB, there is no easy way. So we have actually an open source project which internally uses the DNS, and with Terraform you can actually do the setup. You can, if you want to, let's say, transfer 50,000 records to DynamoDB, or 5 lakh records to DynamoDB, you can do it easily with this setup. If you want to do it manually, it will always it will spend hours and days sometimes to make it work. Now we'll go into the DynamoDB and see how it looks. So far, any questions? We have a lot of people online, but there are no questions so far. Very simple interface. Now we are just creating. So there is no concept of database in DynamoDB. It's just tables. You are creating a table, and your table will serve as a database. So usually, if you are creating multiple tables for your one application, you prefix it or suffix it with some kind of naming convention to identify that these all belongs to the same application. Or the growing trend is that you use only one table for your entire application. So we also, I personally also prefer that. Even though there are a lot of hurdles in that, there are a lot of failures as well. You have to remodel your table multiple times, but it is an interesting learning curve. So you can actually have one table for your entire application, and you store all the data, whether it's a user, if it's an e-commerce application, user, catalog, payment detail, everything stored inside the one DynamoDB table, and then you use the indexes to query it for different types. So here I will go into an example. So I'm going to create one table for which I have a Lambda function, so it will actually inject the rows. I'm giving a partition key, which is my product IDs, and I'm giving like secondary keys, which is basically my this. So if you do not configure, if you go with a default setting, this will cost you. How? So let's see here. So if you go with default setting, it is actually set to provision. That means you can actually use the 5 read and 5 write capacities per second. So these are the unit capacities which is applicable, and that if you create this table and then forget about it, you will end up paying $3.31 at the end of the month. So what I usually also prefer that when you are starting in the development, early in the development, or you have a low use or unpredictable volume based application, always go with on demand. That means if you are not using it, it will not cost you anything. If for some days or for some months, if your application is just sitting idle, or you have developed something which is for your experimentation purpose, if you are not using it, it will not cost you anything. So we are going with on demand. DynamoDB, this is one of the only database. Yes, I think it is one of the database which has the default encryption at rest enabled. So DynamoDB is by default encrypted at rest. In other RDS and Aurora, you have to enable that option. You have the option to actually disable it. In case of DynamoDB, you don't have option to not disable it. By default, it is enabled. You can only select which keys to use from KMS, whether it's your keys or AWS managed keys. But other than that, it will be the encryption is by default enabled, and this uses SSD for the higher performance and throughput. So now it has created a DynamoDB table. There are a lot of things also going on here. So here is the default overview of how my table looks like, how many data that it has. Right now it has no record, so it is showing 0. Streams are basically an interesting concept. I'll come to that. Items are basically, it's a query editor. I can actually fire the scan or the query. If any of you are already using DynamoDB at any scale, make sure that you do not use scan. Scan always exhausts the read and write capacities, as such, and it actually loads all the data. So every time you read something from the DynamoDB table, it will count against your read capacity. If you have it on demand, it will actually start adding those in your bill that you have read this much amount of data. So scan basically scans the entire table. So that's why it is always recommended and preferred to use the query option, in which you are only passing the certain parameters, and based on that you are reading the data. This means if you have 100,000 records in the DynamoDB database, and if you fire the scan, that means it will load all 100,000 records, and that will be billed for all that entire data against that. Because this is not like your regular relational database where you are not charging for every time you fire a select or insert query. In DynamoDB, every time you fire a select or insert query, you will be charged against that, because that is the only billing mechanism available. Other than that, it is serverless. So I'll always prefer that use the query, do not use scan. Use the scan only for this experimental or data previewing purpose. Do not use the scan in your code. It can cost you a lot. Metrics are easily available. Metrics for the DynamoDB are slightly different compared to RDS. Here, everything is against the read-write capacity. If you have given the 5 read and 5 write capacity, once you exceed that, it will start throttling. So you can actually also gauge your performance if you need to extend that or convert that to on-demand. Alarms are cloud watch-based alarms. So here are the capacity capacity activity. We haven't done anything, so it will not show anything. Indexes are basically similar to how we create the indexes into the MySQL or the MS SQL. That those are the secondary, ways to read or query some of the data with different fields faster way. So these are the same concept. It's very popular to create secondary indexes into DynamoDB. There are two type of indexes available in DynamoDB: GSI and LSI. So this one is basically GSI, global secondary indexes, which runs across the partition. Local secondary index you can only create when you're creating the table. So table design, creating a table with right set of configuration and right set of indexes is very important in DynamoDB, because if you do not do that, you have to delete the table, take a backup, delete the table, and then come back and create again. Correct. So that is how you do that. But I still recommend, and we are following that practice of one table for the entire application and use a multi-model inside the table. So it's a very good practice. A lot of even the person, the Rick, the very popular person in the entire DynamoDB across the world, that is Rick Hollihan. He is basically leading the DynamoDB in AWS. He also says the same thing, that use one table for your entire application. You can actually do everything. And they have practically moved almost 100,000 plus microservices of Amazon.com. All of them in one or another way uses the single model, single table concept. So we also prefer the same one table for the entire application. If my application has 15 models, all of those models are configured inside the one table itself, but it is still one table for the entire applications. Now what we'll do is, this also has a global database concept, so you can actually have the DynamoDB access from the multiple regions. This is very, very popular concept because DynamoDB is very popular when it comes to the mobile application backend, which are also mobile apps are global. There are very few regional, popular regional applications. Most of the applications are very globally available. Ad tech, startups for financial data storage and all those things. So which are some of the use cases are by default global from day one. So you can create the global tables with DynamoDB as well. Now, one interesting concept which I wanted to show is that first we'll load the data. So I have Lambda, which is actually ready to insert. Okay, so it has inserted. Now, if we go back here and we check, we run the query. So it has loaded some data. This is how your data looks like. So this is the tree structure, which is a visual, but you can see it in JSON format as well. So this is how the data is. I'm storing this kind of data, but you can have anything that you like. So this is how we are storing that. You can have as much amount of data as you have, and there is no storage limitation here. So this is infinitely scalable. You have no up to capacity as well. So one thing, the reason why it is connected, so the reason why it is used into the serverless a lot is there is no connection management. You just simply point to the table, save the data, read the data, and be done with that. You want to achieve some kind of a, in serverless world, everything is trigger based. So something happens and you execute your code. Something happens and you execute your code. In database case, you have flexibility that you can write the triggers, database triggers, or stored procedures, which something happens will execute your code. But when it comes to the cloud database, cloud NoSQL databases, when something happens into your database, either the application has to take care of it, that a change has been made, or you need a solution in the database itself, which actually gives you the change set, that okay, something has changed, whether you want to perform some kind of action, follow-up action or not, which is a very standard serverless model. S3 has it, DynamoDB has it. There are many more places in the AWS. You will find that there is always some kind of an event which is coming out, which you can consume and resume your remaining operation. So here also you can do that thing with the streaming solutions. So you can actually enable the streaming in a multiple ways. So some changes, you insert new data, you modify the data, you delete the data, and you want to actually then perform some kind of task along with that. You want to trigger Lambda function, which will actually replicate into the some kind of caching solution, which is a very popular use case that whenever you actually save some data into the DynamoDB, because every time you read from the DynamoDB, you incur the additional cost, and it is not also very effective. So you want to store some of those data, stream those data into Redis or Memcache or whichever the caching solution that you want to use. So you use this, you enable the streaming. You whenever thing changes, you actually stream the data to the Lambda, and Lambda will write the data to the target data set. So that is, there are many other important use cases as well. So what we'll do is we'll actually enable a stream, and we'll see one example. So I have enabled a stream. It will take some time to actually show this data properly. But other than that, it has the data. I have enabled the stream, and now I'm going to do a trigger. So this is in a different terminology. This is also called a serverless stored procedures or serverless database procedures. Which something happens to your data and it will trigger those Lambda functions. So Lambda functions become your basically serverless triggers. So I have an existing function which I created. So it just logs the change set. It does nothing other than that. So I'm going to enable that. More of records to process. So what I'll do is I'll go here right now and I'll change the star rating from 4 to 5. Save. So as soon as I save, here it is not connected. You can see. So here you can see the data log that I have changed something. So this is, so even though it is JSON for us, internally the DynamoDB stores it with a data type as well. So sometimes you will see when it is the data output coming directly from the DynamoDB in your Lambda or somewhere else where you are reading, you will see this formatted output. So it is basically adding the field type. So S is a string, N is a number along with that as well. So here is an old image, how it was looking before, and what is the change that we have. So old image has star rating to 5, and this is converted to 4. This is one of the old one. There might be some configuration through which it is not doing that. But this way, you can actually propagate all the changes that you make inside the DynamoDB to your Lambda functions. And you can offload some of the functionality, because when we talk about the serverless functions, everything is either microservices or either functions. All everything is functions. So instead of your one function writing the data or modifying the data inside the database and then triggering the next event, you just rely on the database operation that, okay, change has been made or a modification has been made, and now I want to resume the process. For an example, new order has been received. Okay, so you want to invoke and make sure that the payment has been collected or not, and then start triggering the logistic or the warehousing department that, okay, you need to procure or you need to get this item ready, and then if you are not dependent on the event, then you need to actually write all those logic into the payment or the confirmation function itself, that the moment it receives the confirmation, it actually redirects the event to the other functions as well to resume the operations. So this way, this kind of triggers and this kind of streaming solution helps you to actually orchestrate and chain the multiple functional logic together. So other than that, it is very simple to use. You can actually, this is one of the, out of all the database solutions, whether it's RDS or Aurora, this is very powerful, very popular, and at the same time extremely simple to start with. You do not need to go into hefty configurations. You do not need to go into that heavy thinking logic that which size will be right. You do not need to go into the costing part as well, that how whether paying $100 or whether paying $50 is good to start when you are writing the application. So from all those consideration point of view, I usually suggest everyone to first check, assess whether their application can adapt to DynamoDB, they can use the DynamoDB in their application or not, and then make a strategic decision whether to go with a NoSQL or a relational database. And in that, then your next decision comes whether to go with RDS or Aurora. So Duolingo is again, Duolingo is popular across the world, and they run heavily on the DynamoDB just because of the sheer size, scale, and the flexibility that the DynamoDB provides. They are effectively running the entire application, the entire data set into the DynamoDB. There are a few additional features as well, very interesting. RDS proxy. So one thing that happens, which actually happened in the professionally to me a few years back as well, when we started using the connection-based application from the Lambda. So you need to first open the connection. So that is true for all the connection-based applications. So whether it's relational databases, whether it's Couchbase, some of the, even in the MongoDB, you need to open the connection first. So Lambda, before it does anything, it has to open the connections with the database, then perform the logic, and then close the connection, because the Lambda otherwise will go out of memory or go out of use in the next run, or it is unpredictable. You cannot keep the connection open from the Lambda itself. So that is true for even your container-based application as well, that you need to offload your connection management logic somewhere. Either you need to write inside your application for microservice level, or you need to dedicate create a new DB service which manages all the connections. So RDS has created a very good feature that is called RDS proxy. So which actually manages all your connections on behalf of you. I think we are already, yes, we are running. So I'll just illustrate the purpose. So it actually manages the connections on behalf of you. Again, Gani, to answer your previous questions, the RDS proxy connections are also dependent onto the target instance size. So currently it is only possible to create RDS proxy connections for MySQL and Postgres. It is dependent how many connections that you can create and manage. It is dependent on the target instance size. You can have the flexibility of actually creating 100%, or you can actually also say that I want proxy to manage 50% of the connections, and rest 50% of the connections will be managed by my application. So it's pretty cool. It's kind of a cool, considered to be a cool feature. And for serverless applications, especially for the Lambda base, you do not need to now manage the code, the connection management code from in the Lambda. You just need to point to the proxy. Proxy has the set of connections already, and you are connected to your databases directly without managing the additional per function based connection. This is a huge thing. We had one application in 2016-17 which is using the Couchbase, and we spent like huge, so at least 100 to 200 ms, that is millisecond, is wasted behind the connection management logic every time the function runs, because the entire data set is residing inside the Couchbase, which is connection based. There is no other way to, and the entire application was serverless. So you have to first open the connection, do the logic, and then sanitize the connections. Otherwise, the Couchbase will hang up after some time. So my so the Cassandra is also so the interesting thing with the Cassandra is, so a lot of huge number of enterprises actually gave like a feedback to AWS that they should have a managed Cassandra service, because managing the control plane of Cassandra, managing the cluster of Cassandra is a very resource intensive work. You need skilled resources. You need those clusters, those instances up and running all the time. So the control plane management was a very tedious task, and one of the reasons why it was a very long expected that AWS will sooner or later will release a Cassandra, managed Cassandra alternative, and that is what they did last year. Aurora serverless, it's same as DynamoDB. So if you are writing, if you need a relational database, but you do not want to go with the paid option, so that is a provision capacity, so do not want to pay $50, $100, $200 upfront, you can use Aurora serverless. So it gives you a serverless database for MySQL or Postgres, it actually starts the database. When you fire the query, you can actually warm it up as well. You can set the idle timeout as well. So if you are set the 30-minute idle timeout, if there is no interaction with the database for 30 minutes, it will turn down the database. So again, it is the entire database, entire MySQL, entire Postgres available as serverless. This is a huge key engineering. We are using Aurora serverless as an experiment in one of our Magento setup. It works really well, though there is no SLA attached to that, because the RDS, which is basically a monolithic application, and serverless do not mix together. So AWS is definitely experimenting something really good. And if your application is serverless and you are using you want to use the relational database, you do not want to use NoSQL or any other database, I will 100% definitely say that go with Aurora serverless. It is really really great. So you can try with that. We have used it multiple times. Machine learning. So there are a few interesting things which now AWS is also adding. I'll answer this question after these things because there is nothing left on this. So now actually you can run some of the machine learning functions. So machine learning is basically there are two things. One is machine learning as a service. So you have the dedicated service like a comprehend or text or other services which are dedicated purpose-built machine learning service, or you have the SageMaker, which is your general purpose machine learning service, and you can actually deploy the model and execute whatever you want to. So Aurora has the capability to execute the SageMaker endpoints and the comprehend, that is basically text sentiment analysis, right from your SQL queries. The connection limit will still be there, but actually it is auto scalable, and it will scale the database depending on the load. So if you have 1,000 requests coming, it will actually scale the database automatically because you are not provisioning anything upfront. So there is still a connection limit, but it is basically auto scalable. Now, to answer Kiran's question, how do you exactly migrate on-prem DB to cloud? What parameters you should? So migrating is basically, as I have mentioned in one of the slides as well, typically you can actually go very simple. You can just take the backup of your database. So RDS has multiple engines supported, MySQL, Postgres, you have MS SQL, and you have some flavor of Oracle as well. So you just need to take the backup. You need to create, so there are three options. If you are migrating to the cloud, that means you can actually create EC2 as well and import the data there as well. That is also called lift and shift. You have lifted your on-prem database and run it into the cloud and under the EC2. If you want to go with a managed solution, then you are importing that backup to RDS. So you can import that as well. Very popular. You can almost always go to S3. Every single solution of AWS is tied with S3, similar to how it is tied to IAM, how it is tied to CloudWatch, how it is tied to Lambda, one or another way. Everything is tied. When it comes to moving large amount of data from one place to another place, everything is tied to S3 as well. They have some services which you can look into, DMS. So DMS is basically, it's known as data migration. So that is meant for that. If you want to migrate, even the active migration in which you have two databases running, and you want to do live migration, all of those things can also be done. So that's a very cool service. You can look into that. And the vanilla, take a backup, restore it, import it into with MySQL command or Postgres command, import it into your cloud database. That always works. So that is also your vanilla alternative. But if you have large data set to migrate, you have some kind of conversion to do. There is one very intelligent tool available which Autodesk also used when they moved from EC2 to Aurora. That is SCT, so that is schema conversion tool. So it actually detects what kind of schema changes that you may need to do. It will do that automatically. It will do the assessment as well, and it will tell you that how after this migration whether your database will work properly or not. So there are a lot of tools AWS has built around databases. So these are the databases. These are the migration and transfer, migration hub, database migration. That's the DMS service, which you can look into. Data sync is also one of the data transfer services which you can look into. So there are a lot of services available because database is a biggest business and the revenue pooler for AWS and for many other cloud providers as well. You need to store a large amount of data one or another way to run your applications. You can use the DMS to actually transfer the data. I have, as I mentioned, we have actually open sourced a small solution which is based on Terraform. So there is no easy way to actually load large amount of data in DynamoDB. So we have created this solution to which you can actually import hundreds and thousands of data from S3 to DynamoDB very easily. You will not actually exhaust your capacity as well, and it will just work just fine. So that is coming to the last slide. So I hope I have covered all the options like well. If you have any questions, please do ask. Decision wise, when I need to take a decision, I always start with DynamoDB. Can I use can I use DynamoDB in my application? That is my first question. If not, then I go with okay. Then do we have very small load? Then let's just actually create a database on an EC2 and run it there. If we have compliance and other requirement, then let's go with RDS. If we need very high intensive operational application, then go to Aurora. And it all depends on who is paying the bill. So if I'm paying the bill, I'll always start with DynamoDB, then to EC2, or in now most recently I start going with Aurora serverless as well. But that depends on what kind of user preference that my application has. So these are the questions you can ask, and you can float between the database decisions, because every database is different. Every database is meant for a different purpose. That's why it is called purpose-built databases. And every database will have a very different costing behavior. And if you are not using, your application is not heavily used, procuring or provisioning a large database, even with a reserved capacity, is just waste of money or resources, in my opinion. Okay, then. Any questions which I can answer right now? So, DynamoDB in general is used for that kind of applications where you are doing a lot of read and tremendous amount of read. So gaming industry has a good amount of write and at the same time huge amount of read as well, spread across. And you want almost consistent output in all of your for all of your users. So DynamoDB is really good when you run it at scale. So when you run it at terabyte or petabyte of data, it actually performs really, really well because of the warm internal loading, internal routing, and all those things, and then the partitioning, these things. And one of the reasons why actually Amazon.com built it to support the card. So Amazon was growing and their card was failing for a lot of reasons. So they started this DynamoDB engineering to actually support the purchasing and carting and other features. But now hundreds and thousands of services use DynamoDB. So it is not just about the large volume of data, but it is about the large frequency of read as well. So similar to the S3. So S3 is really good when you have huge amount of read operations, but it is not good when you have huge amount of write operations. DynamoDB on the other side, it's a database as well, but which is really good when you have huge amount of read operations and write operations, and and the large size of data as well. So one interesting story. So Snapchat has Snapchat stories. So they actually migrated the entire Snapchat stories in inbox mechanism to DynamoDB within few weeks to few months, and it was actually running to a million read-write capacity without actually causing any of the issues. And they had issues, obviously, for such a large migration, but once it settled down, there was no issues. If you need to use DynamoDB from any other places, you have to actually go with a public direct API mechanism, which is not advisable because you'll add additional latency. So in that case, I'll always almost assume that if there is no better purpose to use DynamoDB, if there is no strong purpose to use DynamoDB and your actual application is running somewhere else, then I would suggest to actually use a hosted NoSQL solution, which is nearby, so you can save a lot on the latency and the data transfer as well. So RCU is read capacity unit, and WCU is basically a write capacity unit that defines that how much of a read and write provision you have managed. So it is basically with respect to how many read and write operations you can do per second. So it is just a measure of that. By default, if you create a new table, it actually sets 5 read and 5 write. Read-wise, so write uses, every write uses 1 unit, and in one read unit, you can actually do 4 KB of, one read unit is equivalent to 4 KB of data, and one write is basically like 1 to 2 KB. I'm not good remembering the numbers, but there is the capacity, some kind of capacity constraint between the two. Yes, you can find the RCU and WCU. This is very difficult because AWS in general has a lot of services. Each service has huge amount of options. So I remember few things at one point of time, and then I start working on other things, and then I almost always forget the calculations. So when I again switch back to the let's say DynamoDB or RDS or Aurora, I again once in a while I go back to the calculations and see if they have changed anything. This RCU, WCU capacity and formula does not change because that's the entire logic on which the billing works. They will not change anything on which suddenly every customer's billing change. So that remains static. Okay. Those parts remain static. So eventual, consistent, and strongly consistent is basically two forms of how you are writing the data. DynamoDB also has the eventual consistency and strongly consistent. So whenever you are writing new data first time, it's always strong consistent because you write it and when you read it instantly, it will come back as it is. Okay, so that is called strong consistent. It will actually write to all the disk or the replicated partition at the same time and then will return success. So your early initial data, the new data, will always have extra latency. But if you are overwriting or if you are updating the data, it will actually not wait for all the replicated partitions to have the data consistency. It will actually write into of you and then return back, and then it will internally do the replications. So if you have the multi-read or a regional read, or even in the read replica, because read replica also has a latency. So if you are writing and parallelly reading, it is possible that one of your read may have the stale data. Because the data, the place from which it is reading, the disk place from which it is reading has not yet received the updated data. So that is called eventual consistent. In DynamoDB, actually by default it is eventually consistent, but if you want consistent read, you can pass that flag that whatever that you are reading has to be always consistent. It will actually then cost you more because it will consume more read units, but it will give you a consistency. This is the reason why it is also suitable in some of the critical applications like the healthcare or the financial, where they want the accurate data. Imagine the financial application and the ledger. You always want the consistent data back. Or card is something that if you have, if you on one refresh, if you are not all the products that you have stored in the card, it is fine because you can reload and get it back. But in case of financial, you want the consistent data. But that, if you pass that flag, you will have to pay more. So it will actually consume more read capacity. DynamoDB has both. That is not a point for this session. We had that session last time. I have the recorded as well. We have we have one place where we store all the sessions and everything. You can actually. So curiosity wise, I'm as much curious as everyone else. I keep on learning, I keep on doing something, keep on experimenting with new things. fortunately, I have worked with a huge number of customers since 2000, late 2014 to 2015, which are all cloud-based. So I learned, gathered a lot of experience because of my personal involvement and my experience. So this helped me, and the certification is just a byproduct. It's because I'm paying more attention, spending more time, and I'm getting a lot of use cases to work around. So one of the reasons why I could do it. How do we target real-time experience just by interest to achieve? It's combination of both real-time experience and by interest, because it is at times it feels really difficult to actually prepare and sit for the certification. I recently cleared the Kubernetes application developer, and I can tell that last few weeks are like very painful, working from home, managing multiple projects, managing a team of over a dozen people. We have every other week, we have a sprint. We have sprint of 15 days. In some cases, we have sprint of 1 week as well. So we have to keep on releasing the stuff. And we are responsible for everything that we release. So it's very difficult. If you can manage your time, if you have the experience which we can actually connect the dot with, then it becomes slightly easier. Otherwise, it can become very difficult. Okay, I think there are no more questions. So I'll take. Can I get that link so that even I can prepare? So you can just go to this bit.ly AWS Surat. I'll type it here as well. So we have the recordings right inside it. So go for cloud certification. In that, I had a friend with me. He was Kevalya Shah. He's from Deloitte. He's also a super guy. He did a lot of certification from the Google Cloud and AWS as well. So he joined me in that session. We have the session recording in that, along with the slides and other things. Likewise, for this particular session, we have only slides. So I'll upload the slides in the same folder. Any other questions? Great. So I hope I have fairly answered. Practice on assessment on AWS as being engineer. So there are multiple options. So I'll say that the first thing, if you are actually setting up your own AWS environment, do this thing first. Billing and budget, it's really important. You do not want to pay something with chat or accidentally you cost something. The alternate solutions are, you can actually go with options like VSLab. They have the labs option. So you can actually, they will create the AWS environment for you, and you can just practice, and no bill comes to you. QuickLab also has the environment similar to that. Linux Academy also has the environment similar to that. And most recently, A Cloud Guru also has environment similar to that. The only problem with that is A Cloud Guru and Linux Academy are very costly for Indian or Asian countries. So I would suggest to go with VSLab because it's very cheap, and they have the labs option as well. So by clicking on that, it will create the AWS account for you, and you can actually play around with that based on your the lab that you are doing. QuickLab, you can also do the same thing, and then you do not need to worry about the billing part or accidentally starting something and forget to stop that. But real experience comes with going wrong. Real experience comes by failing. Real experience comes when you really struggle to do something. So in that case, I always suggest everyone to create your own AWS account as well. But at the same time, make sure that you do not pay anything extra. Whatever that you start, you stop. Whatever that you store, if you do not need it, delete it. Okay. Put the budgets, billing alerts, so that even if you cross, even if your capacity is only $5 or $10 a month, just create a $10 budget. It will keep on sending you message every time you hit a $5 or $7 or $8. So it's always good to actually learn with real environment. These labs and quick labs are basically restricted environments. Those are moderated environments, so it will allow you to do only certain things and not everything. For other things, you need to go into the real environment, try, fail, and then learn. But these are some of the things which you can try to actually reduce or not pay anything. For first year, if you are signing up new for first year, you actually get free of the free things. So that includes a 750 hour of compute capacity as well. So that is good enough for a lot of learning, even for the database and compute. Okay, so I think with that I'm closing. It's almost half an hour crossed, and I'm at home, so you might be listening. My son is like running around, shouting and crying. So I will stop this session for now, and we'll see you all in the next session. Thank you, everyone. I have.